Hello,
Hello, Ayan. How are you?
I'm good, thanks. What about you?
I'm okay. You are early today, Ayan. You surprised
Well,
me.
you usually start late, so
What do you mean? I usually start late. That's why you are late?
yeah, because you say that you will start in 3 minutes. So then I go to get water, and then that's why it all just happens.
Because usually on Friday I have a lot of classes. Sometimes I want to have break for like 5 minutes at least between the classes. That's why I start late. But now I just connected what I was not expecting. We have just joined, so we are going to start the class now. Maybe I will finish 5 minutes earlier. Okay. Usually online classes, it should be like 45 minutes maybe maximum, but here that's what they asked me to give to teach 1 hour, like 55 minutes. That's why we had a bit longer. Usually if it's 45, just 15 minutes, 20 minutes I talk. After that, students try to solve some question for 20 25 minutes. After that, you get tired and you can have some break. And between, if you have a lot of online classes, if you have break at least for 15 minutes between sessions, it will be reasonable. Otherwise, always looking at the screen and not physically, but mentally, we get tired. Yes, I am.
Is it okay if I'll be back in like 2 minutes? I need to get something.
Yeah, okay, of course. You get something. Also, let me get something. I'll drink some water and we will continue, okay, after 2 minutes.
I am back.
Very good. Ayan, let's start. What happened to Jasmine? She's not feeling well.
No, I don't think so. She hasn't told me anything, but she hasn't been joining classes in weeks. If you want, I can ask her.
Yeah, it's okay. You don't have to, because I think now we have one lady here. She's in charge of this. I think she's going to give a call to her parents. Maybe we will see. Okay, Ayan. So, Ayan, do you also have other private tuition like online or only math?
No, I don't do it online. I do it in person.
So the teacher comes to your house and teach.
Two of them come to my house. For one of them, I go to their house.
Oh my God, you have four different tuition teachers, tutors. What subjects
Yes.
are they? What subjects?
I have extra math apart from your class. Then I have French and piano.
Three more,
Yeah.
including this math. You have four.
Yes.
Okay, I see. All right. Do you ever practice this question with your math teacher? Ayan,
I'm sorry?
do you solve the Sasmo questions with your math teacher?
Yes, sometimes.
Good. All right. Okay, Ayan, as you know, Rifa, are you here? Actually,
No, no.
no.
Yes, no.
Yeah, a lot of students, I think they are traveling and somewhere else. They're trying to join. I know actually you're in the mood of holiday. And Ayan, let's continue anyway. Let's try to do some questions at least for maybe 45 or 50 minutes. Last time, if you remember, we started this at this 2016 S1. After we finish, we will actually start S2. And after the 2017, we have two more papers. And after that, we will see. And we have only 4 weeks left. And let's try to finish all these papers before the Sasmo exam. Okay. All right. We stopped, I think, question 18. Okay. 2016 S1. Right. Okay, let's continue from here. We did 17. Usually, as you know, I am the questions from 15 to 16. I mean, 15 to 25. They are not easy questions. Not so hard, but they are not so easy questions. You have to think. It takes time to solve this. That's why for each question you get 4 points. For multiple choice questions, you get only 2 points. Ayan, can you read the question?
Find the largest 7-digit number which contains all digits from 1 through 7 such that the difference of any two of its consecutive digits is a prime number.
Okay. Find the largest 7-digit number which contains all digits from 1 through 7, such that the difference of any two of its consecutive digits is a prime number. Prime. So we know that actually, when we're just comparing the numbers, we start from the first digit, right? Because the first digits, if it is bigger, then we don't have to compare other digits, because any 2-digit number is smaller than the smallest 3-digit number. The biggest 2-digit number is 99. The smallest 3-digit number is 100. Even the biggest 2-digit number is smaller than a 3-digit number. So here it's saying that find the largest 7-digit number, which contains all digits from 1 through 7, such that the difference of any two of its consecutive digits is a prime number, right? So if I just start from 7, for example, right, and it says the difference of any two of consecutive is prime. So for example, 7 minus 2, 7 minus 3, right? And how about if I just write here, such that the difference of any two of its consecutive digits is a prime. For example, the biggest number, I try to write the biggest number as possible. If I write 6 here, the difference is 1. 1 is not a prime number, right? And how about the second biggest possible number? It is 5. So 7 minus 5, it is 2. So it works. So now the first digit is 7, the second digit is 5. And how about the next number, for example? If it is 4, it will be 1 again, right? If it is 4 here, the difference is 1. 1 is not a prime number. And after 4, what's the biggest next number? That is 3. So 5 minus 3, it is 2. 2 is a prime number, right? And after that, for example, 3, right? Again, I try to write the biggest number after that. So if I write 7, I have already used 7. If I write 6, for example, 6 minus 3, 3 is a prime number. So it works. Let me just write here 6. So because I'm going to use all the numbers, 1, 2, 3, 4, 5, 6, 7. I have already used 7. I have already used 5. I have already used 6. And also we have already used 3. Only 2 numbers left. And the next number, I try to use the biggest number. The biggest number here again is 4. And what is 6 minus 4? It is 2. It's a prime number. It works. So it should be 4. And the 4 minus 2, it is 2. Also it works, right? Actually, but if I write 4 minus 2, okay, if I just write here 4, 2, at that time it should be 1. But 2 minus 1, actually, what is it? It's not a prime number. So I have to change this. How can we change this? 1, 4. How about if I change like this? How about if I write here 1, for example, and 4 and 2, right? Because 4, 1, 2, I cannot write. 4, 2, 1, I cannot write. The only way is then I need to write 1 here. Now, as you see here, 7 minus 5, 2, 2 is a prime number. 5 minus 3, 2 is a prime number. 3 minus 6, 3 and 6, the difference is 3, prime number. 6, 1, 5, 5 is a prime number. 1 and 4, the difference is 3, is a prime number. 4 and 2 is a prime number, because the smallest prime number is 2. 1 is not a prime number. So that is the biggest 7-digit number, where we have just actually used all the digits from 1 to 7. And the difference between any adjacent digits is 1. The prime number. Okay, Ayan, did you get it?
Yes.
Are you sure?
Yes, it's pretty easy.
Very good. How about this question? Ayan, can you solve it? Ayan, do you have, how are you joining this class? Do you have iPad or tablet or any drawing tool? Can you write on the screen?
No.
No.
I do have an iPad, but I don't join from it. It's not very comfortable.
What do you mean it's not comfortable? Do you have a pen?
No.
Hmm. Yeah, actually with mouse. I wish you had drawing tool, especially for maybe for group is hard, but usually I have some other students, I teach them one-to-one. So my requirement is they must have drawing tools. Sometimes I ask them the question, they should be able to write on the screen. And that is a requirement in online learning. Otherwise, only by listening, it may not be so efficient. Anyway, Ayan, just try to solve this question. Okay, let me give you 2 minutes or 1.5 minutes. All right, and after that we will discuss. That question is not so hard, and also at the same time it's not so easy. Let's see what you get. You have,
Tried to do it and couldn't do it.
okay, time starts now.
I think Rifa was asking a question.
No, I wasn't asking a question. I just want to say that I tried to do it and I couldn't. Like I found all of the angles, but I can't find D and E. No, I mean I found E. I remember, but I can't find D.
Rifa, are you talking about question 19?
Yes. No,
Say again,
I
can you
mean
speak a
not.
bit louder? Why your voice is so low?
Okay, now.
Now I can hear you well. Yes.
Yes. I want to see that I found all of the angles except A. I can't find A.
Okay.
Like A90, but
Okay. Good. Let's wait for Ayan 1 more minute. After that, we will discuss together. Okay. That's not so hard question. Ayan, did you get anything?
I'm not done yet. I'm still solving it.
Okay.
I think that EAD is 54 too.
EAD.
Yeah,
Why?
because I don't think it's right, but still, Like when you draw a line from E to the side, then you will have sort of a Z angle. And the inside of the Z, it will be equal to 54 because they're like a cross thingy, and those are always equal. So yeah.
I am first. Did you find this angle?
No.
If you find, let's say this alpha, right? This is a triangle, alpha plus 54, 54 plus 72. These are the sum of the interior angles of this triangle. So that's equal to 180 degrees, right? So from here, what is alpha? 180 minus 54 plus 72, 126. So 126, which is equal to 54 degrees. So if it is 54, if this one is 54, and also this one is 54, so this one opposite the side, let's say this one is this, right? Opposite 54, these two sides are equal. And it says that it is a square, right? That means that all sides are equal. That means that all these sides are equal to each other. So that means that, and also triangle AED, it is an isosceles triangle. And we know that one interior angle of a square is 90 degrees. So this angle should be 90 minus 72. That's equal to 18. And these two sides are equal. That means that if this angle is x, and also this angle should be x. That's the first step. The second step, so from here, x plus 18 degrees, that's equal to 180 degrees. So if you divide both sides by 2, here we have 2x, here we have x. Divide by 2, it is 9. Divide by 2, it is 90. What is x? X equals 81 degrees. So what is it? Angle EAD. Angle EAD is equal to 81 degrees. Okay?
Okay.
Ayan, can you read the question?
The number below is made up of all the digits of the whole numbers from 1 to 2016. Find the number of sevens in this number.
That's interesting question, and it takes time. But here, if you calculate fast, you can get the answer in the short time, maybe 3-4 minutes. Did you understand the question, Ayan, Rifa?
Yes.
Yes.
And before I ask you, for example, let me just practice, okay? After that, you start counting this. It says that, what is it? The number below is made up of all the digits of the whole numbers from 1 to 2016. Okay, Ayan, Rifa, between 1, let me just write here, 2 and 3 until, let's say, 100. How many sevens are used here? How many sevens are there here?
Yes. 10 times?
Huh?
No, 1 minute. 10 times. Or 11.
No, how many, the digit 7 we have here? Because here
11.
we are talking
11.
about the number of
11.
sevens, right?
11, yes. 11.
It is not 11. Look here, for example, here the 7, I have 1 7. And 17, I have another one. 27, I have another one. 37, we have one more. 47, 57, 67, right? And how about 70? Here we have 70, we have 1, 71, 72. And one important thing here is you have to pay attention. And here also we have 77. In 77, we have 2 sevens. And 78 and 79. And continue, here we have 87 and 97. How many sevens? Here we have 1, 2, 3, 4, 5, 6, 7. 7. Plus, how about between 70 here? 1, 2, so from 0 to 9, we have 10, right? And in 77, we have 2. So here we have 11. Plus, here we have 2 more sevens, right? It is 2. That's equal to 21 sevens. Okay. So from 0 to 100, we have 21. Now, can you just find from 100 to 99? How many? And
One.
after that, 1000 to 1999, or just 2000, because 2000 doesn't have any 7, so it doesn't matter. How many? And from 2000 to 2016, how many 7s?
I actually know how. I think so. From 100 to 999, there is 210 sevens. Yes.
Yes.
From 1000 to 2000, there is 2100 sevens.
Mm-hmm.
And from there to there, we have only two sevens. Or no, one. We have only one.
It's 421, I think.
221?
Yeah, yeah. No,
No, it's more than that. It's more than 500s.
no. Yeah, it will be. I will say no.
Because I just, if you just consider, for example, between this 1000 and 2000, right? Not in
Teacher, it will
1000,
be
even 100, for
2020.
example. If you
Can
if
I
you
say?
just check this number, for example, 700 and until 799,
Yeah,
how
the
many
answer
numbers do we have?
final.
701, 700 to 100. Even just here we have 100, at least 107s.
We have 2201 seventh.
Okay.
How are you going to have 2007s if your number is 2016?
But look, when we do from 100 to 999, we just multiply 21 by 100. When we do from 1000 to 2000, we just multiply 21 by 1000.
Really?
Yes, because like from 7 to 97, it's like imagine that it's 100. In 100, we have 21 sevens. So from 100 to 999, we have 10, like let's say 10 100. So we just multiply 100 by 21. That's it.
Okay. All right. Anyway, yeah, again, if you understand the question, the most important thing is understanding the question.
Yeah.
And next step is then actually we think about the technique. Okay, we understand the question now. In what way we should calculate this so that in the fastest way, in the shortest time, we can get the answer. Now, if you just understand the question, let's just do this in this way, because we maybe like this you can count one by one. As you see here, it's taking a lot of time, but here we are talking about digits, right, from 1 to 2016. So now let's just count in this way. First, the first one is number of sevens in one's digits. Okay, how many numbers do we have? Number of sevens in one's digit. Because if you just pick any number, right, here we have 1-digit number, we have 2-digit numbers, as 3-digit numbers, and 4-digit numbers. So it's one's digit number. For example, what are we talking about here? One's digit is, what is it? It is like 7 or 17, right? And 27 until 97, right? And if you just continue here, we have 107, 117, dot, dot, 197, right? And I just continue here, 907, 917, dot, dot, here we have 997, right? And we have already counted here, right? Starting from 0, 0, right? Here we have a 0 until 9. How many sevens do we have here? In each row, we have 10 sevens, right? Because 7, 17, 27 until 97, that one's digit only. How many sevens do we have? Each one we have 10. And how many groups do we have? Here we have starting from 10 to 900, right? How many groups? Here we have 10, and here we have 10 dot dot, here we have 10. So how many tens do we have here? Is it 10?
Sorry, can you repeat the question?
In one's digits.
Mhm.
Not even 1,000. How about if I just write all of them? Okay, until, because until 2016, right? Until 2016, let me just write here 2007, and the 2017 continue until 2000. No. Here before this, actually, here before, 199 1907, right? Here we have 1907, 1917 dot dot 1997, and here we have 2007. Okay, so how many sevens do we have here? Here we have, starting from 7 to 190, we have 20 groups, and here we have one more. In each group, we have 10 sevens, right? From 7, 17, 27, 27, 97. In each group, we have 10 sevens. And how many groups do we have here? 20 plus one more 2007. So here we have 20 times 10 sevens and one more. So here we have 2001 sevens. Okay. The second one is how about in tens digits? Okay. And if you just want the tens digit, what are this? The tens digit is, it's like 70 and 71 and dot dot. Here we have 79, right? The tens digit. And after that, 171, 70, 171 dot dot 179. And next one is continue like this. 1970, 1971 dot dot 1979, right? And the tens digit after 2000, I think we don't have this until here. Again, how many groups do we have here? In each group here, we have again 10, right? Starting from 0 until 9, it is 70, 71, 79. In each group, we have 10. How many groups do we have here? How many groups do we have here? Here we have, again, 20, right? From 70 to 1920. So we have 20 groups again. Here we have 20 groups, and in each group we have how many sevens? Here we have 11. Is it? Seventeen. 20, okay, 20 in each one until 9, only 20. 10. Okay, we have 10 here. Is equal to 200, right? Only 10 digits. I'm just counting only 10 digits. Anyway, and the third one is, uh, here we have, what is it? 100 digits. 100 digits. And what are this? This one is 700 and 701, blah blah. And here we have, what is this? 799, 799. And after that, we have 1700, blah blah, 1799. Okay. And here, how many do we have here? Here we have 100 numbers, because here, starting from 700 until 799, here we have 2 times 100. So here we have 200. So altogether, how many do we have here? 200, 200, 200. So here, the answer is we have 601 numbers. Anyway, actually, it takes a bit time, but here, this is how we count this. Okay, first, right, count all the digit sevens in the ones digit, and after the tens digit, after the 100th digit. In this way, we can count in a faster way. Okay.
Mr. Hassan,
Yes, I am.
but you said that the 107s they're from 700 to like 799, but what about the 1700s?
Yeah, here we have I am from 700 to 799. How many sevens do we have? 100, right?
Yeah,
How about from 1700 to 1799? The same thing, because this one, it doesn't give any contribution. As if starting from 700 until 799. Also, we have 100, right? 107s.
but then in between them, there's also sevens.
Such as,
Like, for example, 1770.
but 70 in tens digit, we just count them in the second group.
So you're doing like each of them separately?
Yeah, in the first one, I'm just counting the sevens which are in the ones digits. And after the second one is in tens digits. And after that, 100 digits.
Okay.
Okay.
Are you writing like that on a mouse or on a touchpad?
Me?
Yes.
Rifa, with mouse, how can I write like this?
You're writing with touchpad?
Yeah, with pen.
Oh, with pen. Oh, okay. Ah, I understood what you have. Yeah, okay. Okay.
What do I have?
Like you have such a thing like mouse pad and you draw on it with a pen, yes?
Yeah, I have also iPads, and even I have Samsung tablet, but I actually prefer, sometimes I use my tablet, but sometimes, most of the time I use Wacom, because Wacom, what I'm using here is a big. It is quite big. I don't know if you can see this. I can show you the screen. Can you see that?
Yeah, I understood what is this.
It is big and is easy to write everything. And with iPads, iPad is a bit small, and I don't know, it's good. For me, teaching with Wacom is much better. Sometimes if I have to draw a lot at that time, I use my iPad or the Samsung tablets, and depends on. But this one is so practical with Wacom. The only thing, the disadvantage is you need to keep your eyes on the screen and your hands on the tablets. That's the problem. Anyway, yeah, let's move to another question. It says that find the sum of the digits of the product. Again, Ayan, Rifa, I'm just reminding again and again, because and if you do not understand, or if this question is not hard, it should not actually demotivate you, because it's very natural. The questions, the last 5 questions, they are a little bit harder. If you do not think a bit differently, if you don't have experience, it may not so be easy. And also, there's no any short way of solving these problems. Okay, and that's why we should get used to it step by step. So in the question, it says that find the sum of the digits of the product. Right, as you see here, 11111. How many ones do we have here? 2016. And when we just multiply this by 2016, right, and the question is find the sum of the digits of the product, we get very big number, and we have to just add all the digits of this number. And usual way, it's not possible, right? It's possible, but it takes a lot of time. So how can we do that? Then we will just look for a pattern. Is there any pattern in this multiplication or not? For example, if I just write here, let's say 2016, right? Let me just write here 1 1 1 dot dot dot, and here we have 1 1. Let me just write here 4 and 5, maybe 6 more. Okay, and here we have 2016 ones, and I'm going to multiply this by 2016. Here we have 2016. So how do you multiply this? First, we just multiply the first digit by this, right? If you multiply this, I have here 6 6 6 6, and here we have 6 6 6 dot dot dot. How many 6 do we have here? 2016, because here the number of ones here is 2016. And if you multiply the second one, it's by 1 1. So I have here 1 1 1. and continue, right? And here we have 1, 1, 1. I have one more 1 here. And if you multiply by 0, it's just 0, starting from 0, 0. And here we have 0, 0, 0, 0, 0. And multiply by 2. So here we have 2, 2, 2, dot, dot, dot. And here we have 2, 2. That's it. Now, if we add this, what we have here, right? And actually, don't forget that each one actually have 2016. If you multiply this, this comes down. Here we have 6. And 6 plus 1, it is 7. And 6 plus 1, it is 7. And 6 plus 1 plus 2, it is 9, right? Others are all the same. 6, 1, 2, 6, 1, 2. It is 9 until here. It is 6, 1, 2. So until here, this was 6, 1, 2, right? Also here we have 9. And now 1 plus 2, here we have 3 and 2 and 2. Okay. So now actually we have how many digits? 2016, one more 17 and 18 and 2019 altogether. 2019 and just 2 digits is 2, 2, and 1 digit is 6, right? 2016. And how many nines do we have here? How many nines do we have here? Since altogether we have 2019, 2 gone, it is 2017 left. 1 is 3, 2016 left, and 3 digits are different. It is 2013. So how many digits do we have here? Here we have 2013. So the sum of the digits then, let me just write here, sum. The first one, the first 3 digits are 2 plus 2 plus 3. And here we have 2013 digits are 9. So here we have 9 times 2013. And here the last 3 digits are 7 and 7 and 6, which is equal to, it is 4, 7, 7 plus 7, 14, 21, 27. So I have here 27 plus 9 times 2013. And before I calculate this, let's see, let me just factorize. This 9 is a common factor. Take this out. Inside we have 3 left. 3 plus 2013, that's equal to 2016. So if you just multiply this, 9 times 6, 54. We have 5. 9 times 1, 9 plus 5, it is 14. And the previous one, 0. 9 times 8 is 18. So the sum of the digits of this number will be 18,144. Any questions, Ayan, Rifa?
No.
Did you understand, Ayan? We didn't do anything very complicated, just in simple way. We are just multiplying, but how we are writing the numbers, you have to pay attention to this. And that's it. And just we need to add these numbers. Okay. All right. Let's move to the next question. Rifa, are you here?
No.
All right. Then I will read for you. In how many different ways can the letters of the word Sasmo be arranged? In how many different ways can the letters of the word Sasmo be arranged so that the two S's are next to each other?
Oh, a lot of.
Not a lot.
Like, not a lot, yes. Like 4 or 5, I think.
Think.
No.
Arrange so that the two S, the letters S, are next to each other.
Teacher, is it 9? It should be 9.
No,
What?
more than 9.
More than 9?
Yes.
Ah, yeah. S's can be not only in the beginning, they can be in the middles.
Yes, that's right.
Then it's
Because if
27.
you write SS right here, for example, I have three
Is it
more
27?
letters, A, M, and O. So I can write either A, M, O. And you can just consider this as one letter, right?
Can I try the answer, please?
Yes.
Exercise answer. Is it 27?
27?
Yes.
No,
I have 16.
no. How did you
Okay,
get
is it
16,
more than
Ayan?
27? Yeah, it's.
I
Look,
just rearranged it in different ways.
no, actually, here, this SSR next to each other means, right? You can just consider this SS as a single letter. So suppose that this SS, all right, let me just denote this by single S. At the time, what letters do we have here? I have this letter S, and A, and M, and O. That's the same question, just using these four letters because this S means SS. How many words you can make? To do this one, Ion, again, just using this counting principle. In the first one, how many letters I can write? Either S or A or M or O. So I have four choices, right? Now the second one, I have already used one letter. How many left? I can use one of three, the remaining three letters. And for the third place, I have only two letters left, either the first one or the second one. And the last one, only one letter left. So I should put that last letter. So what is the answer here then? 4 times 3 times 2 times 1, that's equal to 24.
That is so strange.
Strange? Why?
It just is.
But this is a very important topic in math, in counting principles. It's like
I thought
the
it's
number,
even more than 30.
what?
I thought it's even more than 30, but it's like
No, no, no.
24.
It cannot be more than 24.
Okay.
Why not?
Because here,
That's
for example,
possible.
let's say SS, if it comes in the first place, SS, right? Maybe I can just write here, maybe A, M, O. Or let me just not write the first one, A, O, M. And continue. If the next letter is M, then M, right? And here we have M, A, O, or M, O, A. Either the first letter is O here, O, A, M, or O, M, A, right? How many? 1, 2, 3, 4, 5, 6. If the SS comes in at the beginning. How about SS comes out the second one? For example, here we have SS. 1, 2. The same scenario here. Again, I have 6 different ways. How about if SS comes here, 6? How about if it comes here, 6? So how many 6? 4 times 6. 6, 6, 6. That's equal to 24. It's
That
just like
makes more
asking this
sense.
question. For example, let's say uh, I have 3 different letters. Okay, or let's say Ayan is designing her room. Okay, and she just actually goes to the market and buys 3 different, what is it, some kind of pictures, okay, with flowers. Let's say the first picture's name, actually a beautiful picture, let's we call this A, the second way is B, and second way is C, right? Now if I ask you how many different ways you can put this, maybe the first one will be here, the second one will be here, the third one will be here, right? So how can you do that? Maybe you can just put this as A, B, C, or A, C, B. Or you put the first picture, picture B first, then B, A, C, or B, C, A. If the C is put first, C, A, B, so C, B, A. Actually, what are we doing here? Just actually, we have to locate these pictures into these 3 different positions, right? So for the first position, I can choose any of them, right? Because I have 3. So we have 3 choices here. I have already used one. right? I have two choices here. For the second place, I have two choices. For the last one, I have one. So to get the total number of these arrangements, actually, we just need to multiply 3 times 2 times 1. That's equal to 6. The same thing here. Just here, we have 4 letters here. Okay, Ayan, Rifa.
Okay.
Guys, we will continue. Let's try to finish these questions. Okay, next time we will start a new paper. So find the last digit of this number. Okay. So let me just explain, guys. You just have rest and watch and just try to get some idea. Okay. So maybe if I give you more time, I'm sure that you can solve this question. But to solve this question, again, you need to have some idea. Okay. Before I continue, again, I told you before, one more time, I'm going to tell you. Okay. Let me just, I need a bit more space. All right. What is the question here? We need to find the last digit of, okay, let's solve this and finish the class, okay, for this today, because the other questions also takes time. And you try to solve this question at home, and next time we can discuss, because some questions it takes like 10 minutes for even discussing those questions. And that's the last question, and I will finish the class. So find the last digit of this one. All right. Again, to find the last digit, as see here, 1 plus 2 plus 3 plus until 9 until 2016. Okay. So that means that actually here, after 10, for example, 11, 12, 13, 14, to find the last digit, right? Just the last digit of those numbers is important. Because here, for example, if I ask you, what is the last digit of 12 squared? Actually, I can just write it as 10 plus 2 squared. And the last digit of this number will be 2 squared. That is just 4. Okay, because that means that when you divide this number by 10, okay, the remainder will be 2 to the power of something. And if you remember before, we have, I'm not going to prove this, because if I prove, again, it takes a lot of time. Just you should understand how we are using this. If we have like a to the power of n plus b to the power of n, here n is odd number. Odd number means maybe it is 1 or 3 or 5, 7, 9. We can always write it as a plus b times some natural number n. Okay, always I can write this in this way. All right, and just one example. For example, let's say a plus b. I can write it as a plus b times 1. Or a cubed plus b cubed. That's equal to a plus b. And here we have a squared minus ab plus b squared. And here we have a and b. These are whole numbers or natural numbers. And square of the natural number and product square of the natural number and adding them together also is equal to some natural number. I'm just labeling this by n because I don't need this, but I know that it's a natural number. Okay, so here that's equal to a plus b times n. Okay, that is one thing that we have to know. Another one is another important thing in division algorithm. That's the first part. The second part is, so if I just write here a plus b to the power of n. So n here is anything, okay? I can always write it as a times some natural number n plus b to the power of n, okay? So what does it mean here? Well, how should you understand? If you just divide the whole thing, that is one number, big number, like 2016 to the power of 2016. If you divide it by a, the remainder will be b to the power of n. This is how we should understand this. Like, for example, let's say 12 squared, right? And the question is, if you divide this by 3, what will be the remainder? How can I find this? Or let's say the last digit of this number. So I can just write it as 10 plus 2 to the power of 12. I mean, to the power of 2 squared. So I can just write it as 10 times some number. I don't actually not interested here. I need this number. We are dividing this to a square by what number? And plus here we have 2 squared. What does it mean? It means that if you divide this number, that's 144, I can see that. If you divide this by 10, the remainder will be 4, which means that the last digit of this number is 4. Because what is the last digit of a number? That means that what is the remainder when we divide that number by 10? Okay, so we are just going to use these 2 ideas to answer that question. Guys, let me finish it here, okay? And after that, using these ideas, we will solve this question, the last 3 questions. It may take a bit time, but still, you need to practice these questions at least to get some idea. But next year, when you're participating another level of Sasmo, it will be much easier to understand. And someday we have to start learning a bit more complicated stuff. And I think that's today, I think. Anyway. Okay, Rifa, Ayan, thank you very much. Have a nice weekend. Enjoy your holiday. I will see you next Wednesday. Okay, thank you very much. Bye-bye.
Goodbye. Have a nice day.
You too. Thank you. Bye-bye.
Bye. Have a great time.
Bye-bye, Rifa. Thank you.